Hi everyone, I'm glad to be here to talk about one ubiquitous and very time-consuming task in applied economic research, model selection. It's well known that model selection is also used in many other scientific projects, but in economics it's often used to choose among rival theoretical approaches, promoting opposite political advices, so it is particularly important in our discipline. Model selection often involves data processing methods, dimensionality reduction processes, and finally some estimation, econometric or machine learning estimator, in order to obtain a good representation of the true data generating process. But thanks to Julia, a once unreachable family of these techniques is now available as a feasible option, and we build a package ecosystem upon this. In particular, we can see in this image, we combine machine learning and econometric different algorithms in order to obtain a good balance between accuracy and consistency. We can then run billion of different alternative equations in seconds, in order to obtain black box comparable accuracy, but with a way transparent representation that also, in addition, meets with causal inference requirements. So the important and unique thing here is that we can make a dimensionality reduction algorithm combining econometric and machine learning processes to obtain accuracy and consistency at the same time. Well, but how it works? Long story short, there are a couple of packages, but long story short, this is very fast package ecosystem that works with a simple graphical user interface and provide significant scientific output, both in terms of databases and LaTeX document. And if we dive a little bit deeper into it, we can see in the first package that with model selection.jl, we can combine the data processing like outlier detection and elimination, filtering algorithm like lasso, and core feature selection procedures like all subset regression for both linear and non-linear estimators, to finally use machine learning and fine-tuning algorithm in order to, to get the best and all the entire distribution of different estimation for the goal, for the equation goal. So this result, this model selection result, can after that be used in a model selection accelerator.jl package in order to obtain with additional input from the user about the description of his research topic to develop a LaTeX report where not only you will obtain model selection in deep analysis, but also an AI-assisted classification of related literature. But of course, there are a lot of new contribution that Alan can explain to us.
Well, thank you, Damian. Well, our new contributions can be grouped by 3 categories. First, performance, accuracy, and productivity. Well, in Julia, performance is always welcome. And despite that, we already have a very fast package that is 3,000 times faster than Stata, that is the standard for the econometrics, and 140 faster than R. We thought that we have a lot of room of improvement. First, we reduce our package dependencies, and that's reduce the installation, but also the compilation time by 40%. Also, we implement logic estimator that is 95% faster than Stata. And the last, we implement a new OLS method based on matrix decomposition, new matrix decomposition, Cholesky and Cure, that increased the performance by 36%. At the right, we have a brief chart of the comparison between our solution and Stata. If you can see, the worst case scenario is that we are 10 times faster than Stata. But well, performance is not all, and we think that accessibility also is a must. So we create 2 different solutions for that. One is create a package in Stata that uses the same syntax and returns the same response as the econometrics are used to. But in that case, instead of running in Stata, it's called Julia. That sounds like a contra-revolutionary solution, but we think that for some econometrics people, there's a good way to go, since that they're not thinking about Julia if we're not presenting in a family way. But not to be disappointing, we have another solution that is the model selection GUI.jl package. That is a client-server web application, also it's a package, that shows all the commands of our model selection in a more familiar way. This could be installed by the user usual package way, but also we have a Dockerized method that allows to run the application without need anything more than Docker. So you have an empty machine, you install only Docker, you run the Docker by a public registry, and you get all the package and Julia prepared to run. Also, because it's a backend API, there are more people that can use this solution to create his own interface, such as like mobile apps or another interfaces. And they can use or a fully interactive API documentation based on Swagger to support that. Here we have an example of a common command on model selection, global separation command. They have a lot of variables. And in the right side, we have the comparison to our UI. I will play a little bit and explain the difference. And you can see you choose the file, then the estimator and all dependent variables, explanatory variables will be automatically picked by the file. So it's easy to use. And also all the options will be turning off or turning on, depends on the combination of the variables. It's so easy instead that like remember all the commands that the model selection GSS has. At last, we will show a summary of the tasks that you want to perform, and then the results. The results then with all the raw data and also a summary TXT.
Thank you, Dan. So we've been working on different areas where we can speed up our models. We've been talking about accessibility, so you can have a better access and improve on your productivity with those packages. But we also thought that we could build a productivity increased by having an automatic output, the LaTeX document Demian talked before. So just to show you what it would look like, this is the summary report. We have automatically done all the first report which is necessary to present. You have the one-liner to just generate all this. You have the cross-validation tables. You have the results of each variable and the comparisons and all the statistics needed so you can understand your models, and all brought to you automatically. And we have also improved on gathering the different abstracts for you. So with a one-liner, you just get all the documents. You have an automatic topic analysis and where your query is in those topics. You have automatically list of all the preferred documents, so the literature review you would need, and then you can have the different documents and the selected documents which are more relevant for your research. So not only have we shown you a preliminary document for you to work on, but also the literature review for you to read and improve on the productivity of your work. So in summary, we have make a one of the fastest packages to gather information from econometrics and machine learning. We have improved on performance and accessibility with model selection GUI. And we have also increased productivity by automatizing report generations and literature review. What are we working on? First, we think we have more to improve and get more community by making more estimators, by making better GIS. We are working on that. We think that sometimes precision is not that important, so we are working in FP16, so we can have more speed improvements. And we are working hard also in the time to first answer. So we are working in precompiled custom Julia releases, so you have just fast also the first results. Last but not least, we want to thank our collaborators who couldn't be here. So thank you, Jim, and thank you all for listening.